Okay, welcome all in this class of state estimation. In the previous classes, if you remember, we told that we take number of measurements in place of the minimum number of measurements required, so that even if there is some bad data, then we can find the accurate result. Until unless we find there is a doubt in the accuracy, then the decision making may may not be appropriate, and we may lead to the wrong action. Wherever is not required, we can switch off the line, but whenever it is required to not switch on the line, then it can be switched on, because the data so obtained from the remote terminal unit is not appropriate. That's why we don't rely the minimum number of data, we take some additional data. Say number of states are 2 and we take the 5 data, then we call it as a degree of freedom. The degree of freedom is 5 minus 2 is equal to 3. Now there are two questions arises. First is how the data are collected. Another thing is that degree of freedom. When we say degree of freedom means the additional data you take. Additional, now question is whether what additional locations or what additional data is appropriate data. Suppose the same data is taken directly or indirectly at one place. One data is measured by another meter, and same data if it is measured, then it is of no use. Means these data should be independent to each other. If we are taking additional data or whatever minimum data, say we are taking the 5 measurements, and they should be such that the each measurement will give some additional information, not the same. Say we can say if x1 is equal to x1 plus x2 is equal to 2, there is one equation. If we write another equation that 2x1 plus 2x2 is equal to 4, then second equation is useless, because this is nothing but extension of the first. It is the same as of the first equation. So that's why the data should be independent to each other. Means each data should give the additional information. So that's, and so the two things are. One thing is how the data is collected. Another thing is that what is the minimum data that describe the observability of the system. That we will discuss now. And whatever data is collected through the remotes, and that first of all we should minimize the noise from the signal. The accuracy of the meter is very important factor. We need to convert analog to digital wherever is required. Sometimes digital information is there, sometimes analog information is there. Say if we want to measure the meter, say voltage, it will be in analog. If we want to note down the condition of the transformer or condition whether the temperature is any terminal is open or not, then it is a digital signal. So communication line, sometimes there is chances of the communication failure. The data has been sent, but it has not been received. Such condition is also maybe there. So the so so whether such data is measured at the substation. हेलो हेलो।
यस सर।
यस सर।
सिस्टम कितनी देर से कट गया था?
10 मिनट हो गए थे।
10 मिनट?
यस सर।
तो बहुत ज़्यादा। मैं तो मुझे आइडिया नहीं था सिस्टम ब्रेक हो गया है। तो अब आपने ये काफ़ी लोग छोड़ भी गए हैं इसमें मीटिंग में।
सर कुछ ज्वाइन भी कर रहे थे, उनका हो ही नहीं रहा था।
हाँ, मुझे लग रहा है ये मेरा नेट का प्रॉब्लम था। तो presently there are 8. क्या करना है? Should I repeat whatever what I have explained? हेलो।
नो सर।
ये फिगर एक्सप्लेन किया मैंने आपको।
सर
हेलो।
स्क्रीन शेयर नहीं है आपकी।
अच्छा अच्छा।
जी सर, वो नेटवर्क की वजह से चली गई सर।
हम्म। दिख रहा है अभी?
यस सर।
तो ये मैंने फिगर एक्सप्लेन किया था।
नहीं सर।
एनीवे, तो वी वर डिस्क्राइबिंग दैट at substation side or at the remote side, there are remote terminal units. These remote terminal units may consist of sensors, CTPTs, and PLCs. So they measure the data here at different RTU. They can be say substations, and these data are transmitted. First of all, they are taken in a control buffer with some security bit, and with the help of some protocol, the data is transferred so that it can be again bifurcated data at the receiving end side. So when data is received here at this is called the control terminal unit or main terminal unit, MTU. If it is a RTU, it can be called as a MTU, main terminal unit. And here it is a control system. The data is put into the buffer. Then it is after processing, it is transmitted. This data after transmitting obtained, real-time data is obtained here. This data is maybe displayed depending upon the requirement. It can be displayed in the single line form. It can be displayed in the some Excel sheet. It can be displayed into the any of the form, and then this data is used to take the decision or to change the input fuel level. Suppose if it is measured, it is known that frequency is going down. Some signal is obtained here that the frequency is going down. Then the input fuel is to be increased here so as to maintain the constant frequency. Here there is alarm. Alarm means if some equipment is going below and above the limit, then that system is made as a switch off from the system. And then there is a human machine interface. Human is monitoring the whole data with the help of the main server available here, and everything is available on the screen. On the basis of this control the data. Whatever decision is taken, again it is going to this, and here the decisions are taken. The data measured may be in the form of voltage, ampere, megawatt, reactive power, active power, whether how much tape changing is required, what is the circuit breaker conditions. That data is measured here. This thing is called as a data supervisory control and data acquisition system. So minimum number of data required here. First thing is what is the minimum number of data is required so that the whole system is completely observable. This is the first thing. Then whether the measurement we are doing the at minimum side measurement, or other than plus minimum plus some measurements. So this decision are taken. So first thing is the how the data is measured, and and whatever analysis is performed, analysis means power flow analysis, economic dispatch analysis, load frequency analysis, and security contingency analysis, security analysis, any type of analysis is done to take the appropriate decision, and this is only useful if we do the state estimation. Otherwise, the results may, or whatever action we have taken, that may not be appropriate, or may be wrong decision. So sometime in addition to the data measurement, sometime the problem may be in the data is sent from the RTU, but it is not received because of the communication failure. Such condition may also arises. That's why we take the additional data. So this was about the data collection. Now we will see whether the system is observable or not. How we can say this data is sufficient. So then we do the whether the system is observable or not. So to find whether the system is observable or not, let us see. There are few methods of finding whether the system is observable or not. So for that, let us describe the problem. Suppose there is an n-bus system, and if it is an n-bus system, we can say in general, at each bus you connect some phase measurement unit. But with that, the system will be completely observable. But it is not required that for n-bus system and PMU may be connected. It may happen that minimum to that n value, the system can be observable. So we here suppose the how many system we are to estimate. This is, and if W represents a price, that price to connect the at ith bus, if you connect some PMU, then its price is say W. At ith bus it is a WI, at first bus it is a W1. And whether if PMU is connected on that bus, then it is 1, otherwise it is a minus, 0. So if it can be 1 or 0, means if out of n bus system, say 5 bus at 5 buses, the PMU are connected, then you can say this W1, W2, W5, and out of n. So this cost is to be minimized. Another thing is the constraints, that how many PMU required to be connected, that the fx is the vector function representing the constraints. Constraints means this condition should be satisfied. And now how it is done, let us, this is the problem, and we can explain, or it will be more clear if we take some example. Say, for example, this is our 9-bus system. 1, 2, 3, 4, these are the buses. For example, these are the buses. Bus number 1, 2, 3, 4, 5, 6, 9-bus system. Now we will find out where we have to connect the PMU measuring instruments. Where is to be connected? Either you can say in place of 9. If you connect 9 PMU, then all can be observable, but 9 is not required. With the minimum number of measuring unit, we can observe all the 9 nodes. So, and so you can say at node number 1, if it is connected, x1 will be 1. If it is not connected, x1 will be 0. So it will be 1 or 0, and x1, x2, x3. If the price is same, W1, W2, W3, connecting measuring instrument at any of the bus, if we consider it is a 1, is equal, so then the problem become minimizing the x1, x2, x3, xn. इसको हमें minimize करना है. In place of 9, we can have say 4, 5. subjected to the different conditions. So ax is equal to 1. It is a condition. We will describe what is this ax is equal to 1. देखिए, just to again describe the observability, let us make this matrix A. This A, what is A? A is like, देखिए अभी आपको समझ आ जाएगा. A is like our, जैसे बाइबस बनाते थे उसी तरह की ये मैट्रिक्स है. इसमें क्या है? We put either 1 or 0. If 1 or 2, देखिए, this is the say these are the buses. First number bus, if it is connected with the 2, then it is a 1. Not connected, then it is 0. Otherwise क्या करते थे हम इसमें बाइबस बनाने के लिए क्या करते थे? इसमें एडमिटेंस की वैल्यू रखते थे -by12, लेकिन इसमें हम 1 रखेंगे. मींस जैसे बाइबस बनाते थे, ये 1 और 2 के बीच में transmission, if 1 and 2 are connected through the transmission line, then it is a 1. 1 and 3 is not connected, then 1 and 3 is not directly connected, then it is a 0. 1 and 4 is not connected, so only 1 and 2 is connected, and 1 diagonal will also be 1. Diagonal element will always be 1. So now let us have 2 and 1 is connected, 2 and 3 is connected, 2 and 6 is connected, like this. Let us see this. Say it is a first, this is a first bus is connected with the second bus, then it is a 1, and first bus is not connected any of the buses, then it is 0. Now you see this is a second bus. Second bus is connected with the 1 bus, and 3. Second number, third number, fourth number, like this. Second number is connected with 1, 3, and 6. 1, 3, 6. You see here. Second is connected with 1, 3, 6. Second is connected with 1, 3, 6. तो ये 1, 3, 6 आ गया. Similarly, एक और देख लें आप. 4 is connected with 3, 5, 8. Say 4. 1, 2, 3, 4 is connected with 3, 5, and 6. And one more you see. This 7 is connected with the 6, 8, 9. 7 is connected with 6, 8, 9. 1, 2, 3, 4, 5, 6. 7 is connected with 6, 8, 9. In this way we form the A matrix. Is this point clear? इसका पर्पज क्या है मैं अभी बताऊंगा. उससे पहले हाउ इट इज फॉर्म्ड, इट इज क्लियर और नॉट. ये A कैसे बनाया है, ये क्लियर हो गया कि नहीं?
यस सर.
तो इसका पर्पज क्या है ये अभी आपको समझ में आएगा. नाउ सी, and x is the total number of states or total number of buses. So it is the x1, x2 and transpose of this. Now if you write ax, a ये हो गया, और x is like this, x1, x2, x3, x4. ax, then if you multiply a into x, देखिए a, this row, if you multiply it by here.
एक्सक्यूज मी सर.
Yes.
सर अशोक ज्वाइन कर रहा है सर, उसकी रिक्वेस्ट एक्सेप्ट कर लीजिए. वो नेटवर्क इशू था सर उसका थोड़ा.
अच्छा. Okay. So if you multiply this a with x, here you see, if this row is multiplied by x1, so you can say x1 plus x2 is equal to x1 plus x2, this equation. Next equation will be x1, x2, x3 and x7. Sorry, 4, 5, 6. x1, x2, x3 and x6. x1, x2, x3 and x6. Then you see, then third equation, this will be the x2, 3, 4, x2, 3, 4. This means ax should be greater than or equal to 1. अगर मतलब क्या हुआ, if it is 1, अगर ये 1 है, if it is a 1, तो हमें क्या है कि एक इंस्ट्रूमेंट x1 और x2 में दोनों को मिला के एक ही इंस्ट्रूमेंट कनेक्ट होगा, देन बोथ विल बी ऑब्जर्वेबल. मींस अब यहां देखिए फिगर में x1 पे कोई इंस्ट्रूमेंट लगाए या x2 पे लगा दें तो दोनों ऑब्जर्वेबल. अगर मान लो हमने यहाँ एक इंस्ट्रूमेंट लगा दिया, पीएमयू लगा दिया, तो x1 के बारे में भी बता देगा, x2 के बारे में भी बता देगा. दोनों के बारे में ये इंफॉर्मेशन कैन बी, means both the point 1 and 2, both the buses 1 and 2 can be observable by connect a PMU here. This is, and That's why it is saying x1 plus x2 equal to 1. But it can be, now in the constant it is showing x1 plus x2 is greater than 1, greater than equal to 1. अगर इससे ज्यादा बढ़ा देंगे then no problem, then it will be additional degree of freedom. अगर 1 रखेंगे तो ये मिनिमम, it is a minimum requirement that x1 और x2 को ऑब्जर्व करने के लिए एक इंस्ट्रूमेंट चाहिए और एक से ज्यादा चाहिए, just to increase the degree of freedom. मिनिमम लेकिन एक चाहिए. Similarly x1, x2, x3, x6 इन तीनों को, चारों बसेस को ऑब्जर्व करने के लिए एक इंस्ट्रूमेंट से हो जाएगा और उससे ज्यादा इंस्ट्रूमेंट कर सकते हैं. नाउ यू सी x1 2 3 6 1 2 3 6 इसमें फिगर में देखिए 1 2 3 6 इन सबको ऑब्जर्व करने के लिए एक इंस्ट्रूमेंट लगा सकते हैं आप. सपोज यहाँ पर आपने 2 पे लगा दिया, यहाँ पे 2 पे लगा दिया, देन इट विल टेल अबाउट 1 3 एंड 6. एक पीएमयू हम इन चारों बसेस के बारे में बता देगा 1 2 3 6. ओके, नाउ you see in the third equation what it is saying, that 2 3 4 at bus number 2 3 4 both will be, or all three buses will be observable by connecting a instrument at one location out of 2 3 6. देखिए 2 3 and 6 इनको ऑब्जर्व करने के लिए बस यहाँ पे इसी पे लगाएं तो 2 3 6 भी हो गया. सिमिलरली सपोज ये करना है, यहाँ पे लगा देंगे तो 6 7 8 9 सभी ऑब्जर्व हो जाएंगे. तो दिस इज शोइंग अबाउट. नाउ अब करेंगे क्या, नाउ वी विल फाइंड आउट, सपोज 1 and 2 both the buses are observable by connecting PMU at number 2. और ये 2 पे कनेक्ट होने से क्या हो रहा है, 2 पे कनेक्ट होने पे ये भी 1 3 6 भी ऑब्जर्वेबल है. तो यहाँ से लेके यहाँ तक कर रहा है कि सभी सिस्टम को देखने के लिए, सभी सिस्टम को ऑब्जर्व करने के लिए वी कैन कनेक्ट एट बस नंबर 2. देन बस नंबर 2 यहाँ पे भी है तो 3 और 4 भी ऑब्जर्वेबल हो जाएंगे. 3 इज आल्सो देयर, 4 इज आल्सो विल बी ऑब्जर्वेबल हियर. तो इसका मतलब क्या हुआ, इतनी बसों को ऑब्जर्व करने के लिए हमने 2 नंबर पे पीएमयू लगा दिया, नंबर 1. नाउ 3 4 5 एंड 4 5, अगर 3 पे लगाया तो 4 5 3 4 5 ये सारे कवर हो जाएंगे. तो एक हो गया 2 पे कनेक्ट कर दिया, एक 3 पे कनेक्ट कर दिया. ये 6 7, ये देखिए 6 7 8 है, ये तो हमने 7 पे कनेक्ट या 6 पे किया तो ये भी कनेक्ट हो, ये सारे ऑब्जर्वेबल हो गए. तो इन दिस वे वी फाइंड आउट हाउ मेनी नंबर ऑफ minimum number of, first of all we find out how many minimum number of PMU are required to make the system observable. तो इसमें इसका ये हमने फाइनली some conclusion was drawn here. Say if a linear integer program optimization is used, the following 4 solutions are obtained. जरूरी नहीं है इसके लिए, just to have the complete सिस्टम ऑब्जर्वेबल. हमारा जो लोकेशंस आए हैं, पीएमयू की पोजीशंस आए हैं, वो हमेशा जरूरी नहीं है कि फिक्स. इसमें हमने क्या था 1 4 7 पे लगाने पे पूरा सिस्टम ऑब्जर्वेबल हो जा रहा है, इससे भी हो जाता है. नॉट ओनली दिस, इन प्लेस ऑफ 1 4 7 इफ यू कनेक्ट एट 2 4 7 देन आल्सो सिस्टम इज ऑब्जर्वेबल. इफ यू कनेक्ट एट 2 5 7 देन सिस्टम इज ऑब्जर्वेबल. इफ यू कनेक्ट 2 4 9 देन सिस्टम इज ऑब्जर्वेबल. मींस दीज आर द 4 सॉल्यूशंस. अगर हम इन्हीं इक्वेशंस को देखेंगे, that minimum number of 9 number of system is of 9 bus. This 9 bus system can be observable with the 3 number of measurements. These 3 number of measurements may not be unique, they may be different. So these are the 4 solutions which may give the complete system observable. तो इन पे तो हम इंस्ट्रूमेंट लगाएंगे ही लगाएंगे, पीएमयू लगाएंगे ही लगाएंगे. इन एडिशन टू दिस, अगर हमने एडिशनल किसी जगह पे पीएमयू लगाया, दैट विल बी दी डिग्री ऑफ फ्रीडम. सपोज करिए आपने 2, अब डिग्री जो था 2 4 9, अगर 5 पे लगा दिया तो 1 डिग्री ऑफ फ्रीडम एक्स्ट्रा हो जाएगा. लेकिन यहाँ लगाने पे 5 और 7 से कोई बेनिफिट नहीं है, दिस दे विल गिव द सेम इफेक्ट. तो एक 5 पे लगा दिया, एक इस पे 4 पे लगा दिया, 4 ऑलरेडी इज कवर्ड. 5 and 1 अब अगर हमें डिग्री ऑफ फ्रीडम 5 करानी है तो हम इसको बस नंबर 5 और बस नंबर 1 पे लगाएंगे. Otherwise 3, just to have the system completely observable, we can connect the 3 PMU. But if you want to connect the 5 PMU for having the 2 degree of freedom, we have to connect the instrument at bus number 1 and at bus number 7. Okay, is this point clear or not? यहां तक चीज क्लियर हो गई, क्योंकि अभी तक आपको ये बताया था कि in place of few measurement, in place of minimum measurement equal to the number of system state, we do additional measurement. अब ये पता लग गया कि additional measurements हम कहाँ के करेंगे, कहाँ के लेने हैं. Is this point clear or not? नितिन, हेलो.
Yes, sir.
हाँ, तो now this unit is complete. That was the state estimation.